Guys, it has been a long outstanding problem or question concerning how the universe came about. Alright? And you might know me, Samuel, who did a lot of work in physics and completed Einstein's work on the unified field theory. And they have been asking me questions about my opinion on how the universe came into existence. Right now we have the Big Bang theory, the theory of evolution, and things like that, but we're still not satisfied because the Big Bang theory is violating the law of conservation of energy, because an explosion just can't come out of nowhere without energy. Energy has to create energy. It doesn't make sense. So the Big Bang theory is in like a tailspin. That's on the macroscopic level. Then on the microscopic level now, you have the quantum theory. And they come up with the Heisenberg uncertainty principle of explaining how the universe came. But it too is violating the law of conservation of energy. Okay. But guess what happened now? The uncertainty principle is not really violating the law of conservation of energy. What it says is that if a point in empty vacuum have a spin, which can be like a cos wave, a cosine. If this is a magnetic field in vacuum, they say the uncertainty principle is violating the law of conservation of energy. But that's if you stop there. This doesn't stop there. A changing magnetic field will produce a changing electrical field. And then a changing electrical field will reproduce a changing magnetic field. And a changing magnetic field give you back a changing electrical field. So it just keeps going on and on. And each time it comes on another axis, parallel to the first one, and another one parallel to the first one, and on and on and on. So actually, the universe is given a summation of the Fourier's series of waves. So you know what, guys? Vacuum contains all these little waves. And it means the uncertainty principle is not really violating the law of conservation of energy. It's like, first you have a cos wave, then the next one, perpendicular to it is a sine wave. And then a cos and a sine, and a cos and a sine. So it goes on infinitely. All of these alternating currents. It's like a 0-1 computer. 0-1, 0-1, a 0-1 language. So it ends up that what happened now. The universe is a computer. Just like how me and you have a brain and we are like walking computers. Jesus Christ, who came and tell us about this kind of world, he was a walking computer. God that he talked about, the whole universe is a infinitely expanding computer. It cannot be closed. The universe cannot be closed because in a closed sphere there is no gravitational force to it. And we know through our telescope that it is expanding. So guess what happened now, guys? Sad to say. Sad to say, Jesus Christ was right. Jesus Christ was right. The Big Bang theory is 13.7 billion. 13.7 billion years old. But the uncertainty principle is 13.7 billion years old. Because it's mathematics. It don't care no age. So if this computer was existing as the universe, the body of God, billions and billions long before the Big Bang theory, then you see the universe has always been here. Check this out. Jesus was talking about dark matter, energy. We're aliens from other dimensions. They call demons and devils. I'm going to give you some equation now. And from these equations, you will see how the universe came into existence. Okay? Albert Einstein wanted to bring general relativity and the quantum theory together in one unified field theory. So, in honor of Albert Einstein, my fundamental law is that all equations are equal. It doesn't matter what is the equation. Newton's second law of motion, F equal ma. It's the same equation as Einstein equation equal mc squared. All equations are equal. Whatever you had to this side, same thing you had to this side. Once it's an equation, it's an equation. So, this is how I solve the great problem of bringing the quantum theory and general relativity together that at this moment nobody could do. So let me show you why they call me a super genius. I'm going to solve that problem for you right now. Okay, as I said, since Albert Einstein, this is the equation he used for the atomic bomb, the nuclear energy. So I'm going to start with this equation, right? Watch me carefully now, you know, this is a very difficult problem, but I'm going to make it very simple for you, okay? Because I know it's not just doctors and professors and engineers watching this program. So I have to make it very simple for you. All equations are equal. What's on this side? Same on this side. For energy, let us write energy, c, which is the speed of light. You can put k, c equal to omega. Omega is angular frequency. Okay? And this is the speed of light. K is like 1 over r. It's like radius of curvature. If you square both sides, that's how you get here to be m omega over k squared is equal to the same mc squared. So let me get this part out of the way. See, this is Einstein's equation. The same thing on both sides. Right? Now we can cross multiply. So this is the mass omega over c squared is equal to k squared n. The same thing. Okay? Alright, now right here you can carry this over on this side, right? So I can write this as k squared n minus m omega c. Right, this is Einstein's equation, okay? The solution for mass is m is equal to m0 exp minus kx. This is one possible solution for Einstein's equation, okay? This is very important. So let's go back up to the top here. This, if you differentiate the left hand side and the right hand side, what you get is right. If you differentiate both sides, that's what you get. Okay? Now, if you put in back the c squared on each side, c squared and c squared can tuck it here, another c squared. Then what you have right here is a force, because energy divided by displacement is a force. So you can put F equal to minus F exponential Kn. You see? The force is equal to this, right? Well, what happens is that on each side, the pressure is force per unit area. So you can differentiate this side twice and that side twice. It's an equation, so it doesn't matter. We do anything to do with one side, same thing we do with the other side, right? So it is d squared f upon dx. Carry this over, you get plus k squared f equal 0. Okay? Once you have that, this is the greatest solution of all times, because now if you notice, this is a plus sign, and it made the solution to this problem now sinusoidal, right? That means the solution now is f equal f naught e to the plus or minus I omega t. This imaginary number here make it sinusoidal, okay? So what it means is that since a force is a vector, and a vector is a function, then you can replace a vector by a function, which is the same thing here. D that this is supposed to be a square right there, plus k squared equal that. This is special relativity. This is Einstein's special theory of relativity. And what it does, it tells you how the planets move around in a circle, like or the moon, how the moon move around the earth. This is general relativity. It's a special theory of relativity that I transformed into general relativity. The special theory that I put into general relativity. But you know what now? This equation that is describes how the moon moves around the earth, that means the probability of locating the moon is this. D x the equal 1. That's the probability of locating the location of the moon around the planet Earth. What it means is the same equation that Schrödinger used to set up the quantum theory. So the quantum theory is exactly the same thing as general relativity. Okay? That is a milestone. That's a solution to the unified field theory. Now, this same equation you could write as that in tensor form. See? This is Schrödinger's equation in tensor form. Okay. But guess what happened now? If we go back to the sinusoidal wave function, okay, where a force is the same thing as a vector. This solution, which is Schrödinger's equation, you see, it is that equal the potential Kx can be same thing as omega t. This is a sweet part now.
I use special relativity to wipe out the quantum theory. Special relativity take over all the functions of the quantum theory. It take over the functions of Schrödinger's equation. It take over the function of Heisenberg's equation. It take over the function of Maxwell's equation, and it even goes straight into general relativity. So it's a unified field theory, okay? This is a nice part now. So here's up. Remember, I said it that the wave function that Schrödinger used is right here. Let me clean up everything. Oh, oh my God! Oh my God! This is it. I say that the wave function is equal to exp I kx minus omega t. I said it was sinusoidal. It was sinusoidal. Or you can say A is this is a vector potential. Sine kx minus omega t. So I'm showing you now how special relativity take over all of the quantum theory. You see this? What it means, this is how the universe come into existence now. This is how it's special relativity say even a point in empty vacuum is moving on a time dimension. Okay? So it's like this. An infinite number of points. All of these points are like holes, imaginary. They are just phantom holes. They are just Holy Ghost points. Holy Ghost points. You know what I mean? All of them traveling at the speed of light along the time dimension. And now that I use special relativity to take over Schrödinger's equation, meaning it take over Heisenberg equation, what it is saying is that from this sinusoidal wave up here that I put to be special relativity, it's traveling around each of these. That means special relativity is doing like Heisenberg's uncertainty principle, predicting that even a point in empty vacuum have a spin. That's the Holy Ghost. That's the Holy Ghost. Instead of saying it can be a particle or a wave, I united them together and call it a vortex. A wave with a center of mass. Now, if it have a spin, that means it is a positive pole. It's a north pole. Each of these are north poles and they're repelling each other and causing an expanding universe. That's why the universe is expanding, not because there's a bomb. This is the Holy Ghost. They call it geodesic deviation. I don't even have time to write down that formula. But guess what? It's not even violating the law of conservation. Because now that special relativity have everything together, right? This spin, these holes are like virtual positrons. So you have virtual electrons going in the opposite direction to these Holy Ghost particles. So these spin create like a magnetic field to counterbalance these electrical movement, which is the electrons moving in the opposite direction. So when you look at me, that's what you see. You see a wave, a vortex. So guess what happened now? Let's go back up to here to explain how the Holy Ghost, God's Holy Ghost Spirit, created you and me. Alright. When I put that the pressure, the F, actually, it's not just Heisenberg's equation alone predict that. Maxwell equation predict that when the source is zero, all points in vacuum have a spin, and it's an inverse square law spin. All kind of inverse square law force is conservative. So let me this time let me take it from this angle, from Maxwell's angle, to show that every point in empty vacuum have a spin. This is Maxwell's equation. Let me use back the same vector potential. Oh man, physics is so sweet. C squared dt squared equal minus 4 pi J over C. This is Maxwell's fourth equation, number 4 equation, right? Remember this potential here. I showed you that it is the wave function. Shooting as wave function, and it's the same thing. A function is the same thing as a vector, and we use the vector force, right? Okay, so you can actually see that force multiplied by velocity is equal to power. This rate of doing work, right? So power divided by C is equal to the force. Okay, so right here, current on this side, if you take this C and multiply this side, C, for this is current, C multiplied by A would give you power, this W, right? So I can write Maxwell equation like this. I could put that for Maxwell equation and take out this C, you see? So power per unit area is the same thing as current. Power per unit area is the same thing as current. That's Maxwell's fourth equation, okay? Now, when the current is zero in empty vacuum, Maxwell equation is saying that every point in empty vacuum have power, God's Holy Ghost power. You get that? God's Holy, even a point in empty vacuum can be assigned a power, and the power will be just like the same sinusoidal sine kx minus omega t. That's why the universe exists, because when you're looking at me, you see God's Holy Ghost power. It's a wave. It's Holy Ghost power. But let me show you now. Let me show you now the unified field theory, right? Start with F equal ma. F equal ma. Newton's second law of motion. You multiply both sides by displacement. Guess what happened? Guess what happened? The technology, if I go too deep in certain technology, gonna blow your mind, right? Because even the physicists and the engineers and the professors that can't understand it. When I talk about Maxwell's equation, this is Maxwell's equation, right? I'm gonna try to make it simple for you, because I don't want to blow your mind, because this takes you into miracles and magic, mystic universe, right? But let me just finish off what I was saying first, that you can, and then I take you to the simple one that people can understand. The Maxwell equation, I wrote it as df right, that's Maxwell equation, you know? This is the vector potential that I changed to a force, right? And guess what happened now? This kind of technology is way, way beyond belief. And it's way too far for you to understand. But let me give you a quick glimpse. It's actually positive 1. Positive 1 is the same thing as negative 1, negative 1, take the square root. Let me start to make it simple. Positive 1 is the same thing as 1. 1 is the same thing as the square root of minus 1 minus 1. Okay? That is equal to the square root of minus 1 square root of minus 1. Okay? Which is equal to I times I, imaginary number. When you square that, it's equal to minus 1. So right here, minus 1 is equal to positive 1. This technology will blow your mind. You can substitute it back into Maxwell equation right here. Just like that. This technology is far beyond the 20th century. You see what I'm saying? But if you want, you can keep the minus sign here and put a high right there and get the solution. And get the solution as a sinusoidal wave. A solution to this is special relativity. Go back to Cauchy. You go back to Cauchy. Cauchy theta. Because Cauchy theta is equal to Einstein's relativistic constant. That's Cauchy. It's an imaginary wave. But this is going to be too complicated for you. So let me show you. Let me go to simple ways how special relativity is the same thing as the quantum theory. This is Newton's law. Okay? Newton's law. Follow me now. Follow me. Follow me. Follow me. Follow me. Times x. Energy. Energy. Energy equal that. Right? Mechanical energy can split in two. You can still write it as the same thing, right? Kinetic and kinetic. Change this one to half m x squared omega squared, right? Actually, this can put as the momentum squared upon 2m. And it's energy, right? Then you can put the same energy equal to P upon 2m plus a half k, call it that, square. This is Hooke's field law. Hooke's H-O-O-K-E-S. Hooke's field law equation. It is the work energy theorem. It's the work energy theorem, right? So let us write this as this will be a square. Let us write it as an operator. This operator here is I H squared over 2m. Right? And plus back this. So actually, this is Schrödinger's equation. It's the work energy theorem. It's the same thing about the moon going around the earth. It's the same work energy theorem. But let me write, the work energy theorem is the same thing as the elliptical motion. P over 2 me, the square root of that, squared by Pythagoras theorem, this is square, and this is x over 2e over k squared. Right? This is an ellipse. It's the same work energy theorem as down here. This, right? So if you put a wave function there and a wave function there, that is Schrödinger's equation, right? Schrödinger's equation is the same thing as Heisenberg equation, because a wave function is the same thing as a vector, which is Heisenberg vector, right? And a matrix is just a collection of vectors, right? So this, you can turn it into a matrix right here, call it P naught, and square it. And this, you can turn it into a matrix right here. You can call it X naught and square it. And this is Heisenberg equation. So you see, Heisenberg equation is the same thing as Schrödinger's equation. It's the same thing as the work energy theorem, and the same thing as special relativity up here. Right? Remember when I started with it, the same special relativity. And this is the same thing as general relativity for the motion of the moon around Earth, and I'm done. That's how the universe came into existence. Because I make special relativity equal to Heisenberg equation, Schrödinger's equation, Maxwell's equation, all of them, and then put it to be a special case of general relativity. So that's the unified field theory that Einstein tried to solve, or tried to teach us. And it explained how the universe came into existence, because I use Heisenberg uncertainty principle with special relativity to say all points is moving along the time dimension, even if it is just a hole, and it's a positive North Pole, and that hole is the Holy Ghost. North Pole, positive position, is a phantom position moving along the time dimension. It has a spin around it, since it's the same thing as Heisenberg uncertainty principle, saying that every point have a spin, and that's a current. They repel each other to give you an expanding universe, and the law of conservation say that the spin, magnetic field, will counterbalance it, and it's in Maxwell's equation.